In the previous video, you are reminded of the danger in using sine formula to find the angle, especially in the SSA situation. If you use the sine formula, it turns out that there are two possible values for the angles, right? The calculator will only give you one answer, but the other answer is equally important, right? Usually, there's no way to tell which is the correct answer. So, the advice I gave you last time was not to use sine formula to find the angle. Alright? Always use cosine formula to find the angle. It is the unambiguous way. Right? But sometimes you cannot help it. Sometimes when you only have SSA information. So in this video we come to this notorious SSA ambiguous case. And because there are many outcomes in the ambiguous case, so let me review all these outcomes to you one by one. All right. So now there are four cases, right? We have the 4, the 30 degrees, and the other side, right? I will change this one to 2, 1, 2, and then 3 and 5 in the next situations, and see what will happen if you change the red number along different examples. So in the SSA situations, there are two ways, right? The first is the blue one. We use the cosine formula to find L. The second one is the orange one. We use sine formula to find theta. All right, mind you, if you can help it, use the blue way. The cosine formula usually is the more unambiguous way to find the answer. All right. If you're running out of options, then you use the sine formula. Okay, let's start with the blue. All right. Now, normally you can only apply in the SS and you can normally apply the cosine law in the SAS situations. That means with 4 and 1, you need this angle, right? You need the angle between the 4 and 1 to find the opposite side. But this time we do not have this blue angle, so we have to put we have to put L into the cosine formula. So we have 4 square and L square minus 2 times 4 times L cosine 30 degrees, right? And that equals to the square of 1. All right. Now that's how we apply the cosine formula with the SAS situation. But one of the side is the unknown. All right. So now we have a quadratic equation in L. We have a quadratic equation L. When you simplify the equation, it becomes L square minus 4 root 3L plus 15 equals to 0 when you simplify this quadratic equation. Alright, so the solution to this quadratic equation is the solution to L. Alright, so if you should do it on the calculator, you discover that unfortunately the discriminant is less than 0. Alright, let's see what the discriminant is. B squared minus 4AC, so it's minus 12. Alright, it's less than 0. So that means there is no solution to L. There's no solution. Such a triangle is impossible. Right? It's never possible to draw a triangle. In fact, if you put them into scale, it would be something like this, right? This is the 4 units, right? At the bottom line, I don't know how long it is, right? So let me put it in dotted lines. I don't know how long will be this one, right? This angle is 30 degrees. So you discover there is a certain distance between this point to the back. If the red line is too small, all right, it will not touch the bottom. It will not touch the ground level, right? Now this is what happened. This number 1 is too small. It is not long enough to reach the bottom. Therefore, you do not have a solution, all right? So let's do that again on the sine formula, right? If we cannot use the cosine formula to find L, let's use sine formula to find theta, and let's see what happens. All right. So we have sine formula. Sine theta divided by 4 will be sine 30 divided by 1. Am I right? This is how the pairing of the sine formula. The sine of each angle is paired up with the length of the opposite side. All right. This pair. All right. So this is how sine formula is pairing up. So we have sine theta equals to 2. All right. Now that's funny because we know sine theta is only lying between 1 and minus 1. So sine theta cannot be true. So this will also tell us that there's no solution for theta. Alright, so you can see the mathematics is going to tell you that there is no reason from two different ways. If you do it in the blue method using cosine formula, then it is telling you there is no solution because the delta is negative. Alright, this is how the equation is telling you there's no solution. On the other hand, if you use sine formula to find theta, this is how the equation is telling you there's no solution. Right? There's two ways to tell you the same thing. Alright, so that is for the first case, where you have SSA, but there's no solution. Alright. Now, and then move forward to the next case when the red line becomes 2 units long. Alright. So I'll try to repeat the same thing. Alright. So let me copy the entire equation. It's just the same equation. What's the difference? The difference being the red number is now changed to 2. Alright. So it is an SAS cosine formula once again. Alright. So it turns out the quadratic equation becomes L squared minus 4 root 3L plus 12 equals to 0. Right? Now try to do it on the calculator. You discover that L is twice root 3. Right? It's a double root. It's a repeated root. Alright. We can also discover it is a repeated root because the delta is 0. Right? The delta is 0. So it means that there is one solution. There is one solution. It turns out that in the real diagram, it is something like this. Alright. Once again, the bottom line, I don't know how long it is, but this line is making 30 degrees and 4 units. 4 units and 30 degrees. It turns out that the length of 2 is exactly this one. Alright, this is exactly the length of 2. So if you remember the swinging arm we just talked about, alright, it's like a straight line swinging on this point, alright. The red line barely touches the ground level, touches the dotted line, so that this is a right angle, alright. And this is how the repeated root, the red line just touches the dotted line, alright. Now let's do that again for the sine formula and see what the sine formula tells us about the double root, alright. So once again, let me copy the sine formula. Here it is, alright. And the difference is the red number 1 becomes number 2, alright. And if you do it on the calculator, it turns out that sine theta is 1. When sine theta is 1, theta is 90 degrees or 180 minus 90 degrees. Am I right? Theta is 90 degrees or 180 minus. For sine theta, the inverse trigonometric function is theta or 180 minus theta. Now here is where the double root comes from. Theta is 90 or 180 minus 90. 180 minus 90 is also 90. So the two solution becomes 1. Theta is 90 degrees. Alright. So now we know in this case the length of L is 2 root 3 and the angle of theta it will be 90 degrees. Okay? So that's how the SSA situation turns out to have a double root. And that corresponds to a right angle triangle. Alright? Now let's look at 2 more cases. Alright? It's just the same, only that we change the red number. Okay? So once again, we use the cosine formula to find L. We have 4 squared plus L squared plus 2 times 4 times L cosine 30 degrees is the square of 3. Alright, so that's the cosine formula. And that cosine formula becomes L squared minus 4 root 3L plus 7 equals to 0. Alright, now if you do it on the calculator, there are 2 solutions for L. L is 5.7 or 1.23. Alright, so there are 2 answers. Now what does that mean? Once again, if you look at the real diagram, you discover that the line L is, the triangle is kind of like this. Alright, so this is 4 units, this is 30 degrees, right? So the red line is the swinging arm. Now this time the red line, if it is 1, then it is too short. Right, in the previous 2 examples. If it is 2, then it is just right. Alright, it's 2, then it is just right. You touch the ground level at one point. Now, if it is 3, then it is too long. It will swing at 2 different points. Alright, the length of 3 will be swinging. Alright, with 3 here and a 3 here. So now you see there are 2 possible values of L. One of them is shorter, the other is longer. The shorter option being this one, right, is 1.23. The longer option being this one, right, is further away. It's 5.7. Alright. So now there are 2 solutions for this ambiguous SSA situation. The actual diagram is like this. You see there's a shorter L and there's a longer L. Now let's do that again on the sine formula to see what does it show in the sine formula. If we want to find theta, so sine theta divided by 4 will be sine 30 divided by 3. Alright. So it turns out that sine theta will be 2/3. Alright. You do it on the calculator. Theta will be 41.81 degrees, right? So that is the answer. But mind you, there is also a hidden answer, right? That is 180 minus 41.81, right? Theta or 180 minus theta. So there are 2 solutions for theta. Theta is 41.81 or is 138.9. Alright, so there are 2 solutions. Alright. Now you can see once again on the diagram on the left hand side. Theta, we are talking about this angle. Alright, this is theta, right? The angle between 3 and L. The angle between the red line and the blue line. So once again, there are 2 possible values. Now you can see, alright. On the far side, it is 41.81 degrees. Because it is the acute angle. On the near side, it is an obtuse angle. That would be 138.19 degrees. Alright, that would be this angle. Alright, that would be the obtuse angle. Oh, sorry, it should be 138.19 right here. Okay. So we have 2 sets of answers. Alright, and note also the matchup of the answer, the pairing of the answer. The 5.7 shall be paired with 41.81, alright, because it is on this triangle, the larger triangle. That would be the longer L and the smaller theta. And then the other set will be on the smaller triangle, alright, in the obtuse angle triangle. That 1.23 shall be matched up with 138.19 for the obtuse angle triangle, alright. So now that is the most complicated case for the SSA ambiguous case. It is the 2 solution situation, right? When the swinging arm, when the red line is long enough that it reaches 2 points on the ground level. So you have an acute angle and then angle triangle, and then you have an obtuse angle triangle. Okay, as you can see, there are 2 solutions from both the cosine formula and also the sine formula. Alright. So finally, let's look at the last case, right? No, so what happened to the last case, right? So we do that again and see what happened, right? So we run both solutions. Now I change the red number. Instead of 3, it becomes 5, okay? It becomes 5. So let's see what the formula tells us. The quadratic equation becomes L squared minus 4 root 3L minus 9 equals to 0. Alright. Now it turns out there are 2 solutions. L will be 8.05 or minus 1.11. Alright. Should be minus 1.12, but never mind, since it is a negative number, so the length cannot be negative number, so we reject that value nonetheless. Alright. So that is to find the L using cosine formula. Now, as you can see from the diagram here, that would be L. And the triangle SSA with L will be 8.05. So where is that minus 1.12? That minus 1.12, it turns out that the red line is too long. It is too long that the other solution goes in the wrong direction of the angle. Alright, the other line is too long that it goes to the other side, to the wrong side of the angle. So let's do that again for sine theta, right? For sine theta, it goes like this. So we have sine theta divided by 4, the bottom right corner, alright? We have sine theta divided by 4 is sine 30 divided by 5. So we have sine theta is 2 over 5. So from the calculator, the answer is 23.58. But there is also an additional answer, 180 minus 23.58. So 2 answers, all is well. But note that because one of the angle is already 30 degrees, alright, so you cannot have an answer 156 because that will make the angle sum of triangle greater than 180. Alright, so we cannot accept this answer. We have to reject this 156.42 because that will make the angle sum of triangle greater than 180. So let me take you back to the diagram on the far left, alright, the bottom left corner. So what is that 156.42? You see, that will be the angle over here. Alright, so the negative blue line and the 156.42 angle, the angle that is too great, is on the wrong side of the 30 degrees, right? The 30 degrees is on this side of the triangle. But the rejected answer, they are all on the wrong side of the triangle. So this is the last situation where you have 2 sets of solutions, but one set should be rejected. Alright, so at the end, you got only 1 set of answers. So these are all the ambiguous case for the SSA situation. You can use the cosine formula, you can use the sine formula. Alright, so this is the more complicated cases. Pay attention to this one. Thank you.